Hello, this is Jason Powers. I'll be teaching a lesson from my Intro to Mill Writing course. It's estimating weights of objects. Today is 6/2/2023. So let's get started. So why do you think that it would be important for us to know what the weights of certain objects are? Yeah. Exactly. We need to know what proper rigging that we need to have. We need to know what our slings are so we can estimate those sizes. Not everything that we get out in the field is going to have a certain weight on it. A lot of the things that we get, we know from when they come off the truck what they weigh. We'll have an estimate of what it is. Another way that we could do this is if we had a crane or something that we were picking it up with that could estimate the weight for us. We could do it that way, but we don't always have those things available to us. So one of the things that is important for us to be able to do is to be able to calculate out or have an estimate of what the weight is. That way we can get the proper rigging to be able to move it to wherever we need to go, or if we're going to be moving it with a machine, to make sure that the machine has enough strength to be able to lift that particular object. So the first thing that we're going to do is we're going to work with cubes. Now, why do you think that we would want to use a cube when we're trying to figure out what our weights are for our objects? Yeah. Exactly, because most of the stuff that we have out there, we can break it down into simple shapes. It could be a square or a cylinder shape or a rectangle, triangles, different things like that. We can break most of the machines that we use, or most of the boxes that we lift, or steel that we lift, or different objects like that, into those simple shapes. So we're going to start with a cube, and I'll give you some information, but I'll also be looking for some information from you. So the more that you participate, the easier that this is going to be for both of us. So as we start, what we need to do to figure out the weight of an object is to figure out its volume. Now, who in here remembers what the formula is to figure out the volume of a cube? Yeah, exactly. Length times width times height. We abbreviate that L, W, and H. So if I'm going to write these dimensions up for my cube, we're going to take some simple measurements to start. We'll go 2 feet for our height. We'll go 3 feet for our length, and we'll go 4 feet for our width. Now, you do have your calculator, and if you decide you want to use your calculator, you're definitely going to need it as we start to go along, but for some of these early ones, it's probably easier just to do it in your head. If you want to write it out on paper, that's perfectly fine. I see a couple of you taking notes, so that's definitely something that would be good for you to do. So if I'm multiplying length times width times height, I take 2 times 3 times 4. 2 times 3 is going to give me what? 6. So then I have 6 times 4, which is then going to give me an answer of 24. And what's that measurement going to be? Yes, feet. What kind of feet? Cubic feet. Correct. The reason it's cubic feet is because we're multiplying 3 numbers together. If we were only multiplying 2 together, then it would be squared. So that's why we get cubic feet. So we've got 24 cubic feet. That's the first part of what we need to know to figure out the weight. Second thing we need to know is what this material is going to be made of. Now, most of the things that we move out in the field, what are they typically made of? Yes, wood, you are correct, but I don't have the weights for wood. So I know that typically when we're dealing with boxes, things come packaged in crates or different things like that. But I choose not to use wood because not all of our machines and not everything that we get is in a wooden box. Sometimes it comes straight off the truck as the piece itself. It's just wrapped in plastic or something like that. So I choose to just use steel. Anybody know what the weight of steel is per cubic foot? All right, per cubic foot, and I'm going to write this over on the side. is 490 pounds per cubic foot. So if this is my cube, I've got a solid steel cube. This could be approximately the shape of a motor or something along those lines. We know that it's going to be 24 cubic feet. So I take that 24 and I multiply it times 490. This is where your calculator is going to come in handy. I'm going to go grab mine. We don't have to put in that it's feet in the calculator to be able to calculate the weight, so you can just take 490 times 24, and what do you get? 11,760, that's what I get to. So that is the approximate weight of what our cube is. So now that we've got that, I'm gonna go ahead and erase this so we can move on to the next thing. How often do we have something out in the field that is exactly 2 feet by 3 feet by 4 feet, or exact measurements? Right, not very often. So one of the things that we're gonna work through here is actually figuring out if we have things that are in feet and inches, or feet, inches, and fractional inches. So the way that this is gonna work is I will steadily start making these harder and harder. So we'll start out with something that's really easy, like we just did with the feet. Then we'll do feet and inches. Then we'll do feet, inches, and fractional inches. So that'd be like your halves, your 3/4, your 7/8, those different kinds of things. And then once we feel good about that, then we will switch over and we'll do the same activity with a cylinder. Cylinder is going to be a little bit different of a formula. When we get to that point, then we will go ahead and talk about what the formula is for a cylinder, and we'll work through that problem as well. So when we are dealing with feet and inches, there is an important thing that we need to know. The formula that we have to figure out weight deals with 490 pounds per cubic foot. So if I have a box that's 1 foot by 1 foot by 1 foot, that's going to give me a total volume of what? Exactly, 1 cubic foot. So that we know that that weighs 490 pounds. So another way that we can write 1 foot by 1 foot by 1 foot is what? Correct. 12 inches by 12 inches by 12 inches. Why is this important? Because if we have something, sorry about that, phone rang. If we have something that is going to be feet and inches, or feet, inches, and fractional inches, we're going to need to convert that from inches back over to feet. So take 12 times 12 times 12. Tell me what you get. $17.28. That is our magic number, and I'm going to write that over on the side as well because it's something that you're going to need to know. When you are converting from inches back over to cubic feet, you're going to have to take the number that you find and divide it by 1728, because there are 1,728 inches, cubic inches, in 1 cubic foot. So 1728 is our magic number. Everybody good? I can erase this? Okay. So let's go back to our cube, and we'll make it fairly easy. That way we can keep it in our calculator. We'll do 2 feet, 2 inches by 1 foot, 8 inches by 1 foot, 3 inches. So the first thing that we're going to want to do is we're going to want to convert all of this over to inches. Could you put it in your calculator as feet and inches and still get the correct answer? Yes, but if you're out in the field and you don't have your calculator, I would rather you change it all over to inches and then convert it back for your feet, because then you know that you're not going to make an error putting it in the calculator. So by starting out, 2 feet 2 inches is how many inches total? 12 inches in a foot, 12 times 2 is 24, 24 plus 2, 26, correct? So you got 26 inches times 1 foot 8, so 1 foot is 12 inches plus 8 is going to give you 20. And then 1 foot 3, 12 inches plus 3 is going to give you 15. So now we can go ahead and do our math. You can just plug all those in. Again, you don't have to put it in as inches. You can just plug those numbers in. So you've got 26 times 20 times 15 is going to give you 7,800 cubic inches. Now, if you remember, like I just told you, our 490 works with what? Cubic feet, correct. So what do we have to divide this 7,800 cubic inches by? The 1728 that we just figured out. So you should still have that 7,800 in your calculator. If you cleared it, that's okay. Take your 7,800, divide it by 1728. That's going to give you, we're going to round to the nearest thousandth. How many places after the decimal is thousands? 3, correct. So we're going to have 4.514. And this is our cubic feet. Now we can take our 490 so we can figure out exactly how much this cube weighs. So we take our 4.514 times 490. And what do you get? If you left it in your calculator, you are going to get a little bit different answer than what I have. That's why I told you it's important. We're going to round everything to the nearest thousandth. That way we're all on the same page. And by the way, this is how I would do this if I was out in the field. I know I haven't given you an answer yet. This is how I would do this if I was trying to calculate this out in the field. I would write every single step out. That way, you're usually going to be working with a partner out in the field. And if you want to try to figure out what the weight of the object is, you want to check each other, then if you have everything written out and you get 2 different answers, you can see where those different answers might have come from. So you take and write everything out, and I'm going to recommend that you do this for every problem that we do. That way, if we get different answers, I can go ahead and I can look at what you have on your paper and we can see what we have different. So if you round it to the nearest thousandth and you put that in your calculator, you should have gotten what? 2,211.86. So are we going to worry about 860 thousandths of a pound? No, because when we're doing our rigging, any of our stuff is not going to be down to that precise of a measurement. So we're going to round this to the nearest whole number. So this is going to be 2,212 pounds. That's the approximate weight of a steel cube that would be that size. All right, any questions on that one? Everybody see where I got all my numbers from? Just converted all the feet and inches over to all inches, divided, rounded, used that 490 as our number. All right. So normally, what we would do here is we would do a few more problems where we have feet and inches. But for the sake of time, we're going to go ahead and move forward a little bit. Since there's only a couple of you in here, we're going to go right to feet, inches, and fractional inches. So let's go with 2 feet, 4.5 inches times 1 foot, 11 and 3/16, and 2 feet, 5 and 7/8. Now, I don't know about you, but I don't know all of these decimal equivalents off the top of my head. And if we're going to convert all these over from feet and inches and fractional inches over to all inches, we're going to need to know what those decimals are so that we can properly put it in the calculator. So I'm going to start out just like I did before. I'm going to take that 2 foot, 4.5, and I'm going to convert it all to inches. So 2 foot we know is 24, plus 4 is 28. And then what's a half inch as a decimal? That one's a pretty easy one. Correct, 500 thousandths. Then we're going to multiply that by 1 foot 11 and 3/16. All right, so this one I don't know. I know the feet and the inches, but I don't know my decimal. So what we're going to do, if you have your Construction Master calculator, you're going to put in 1, and then you see this button that says feet right here. You're going to go ahead and hit that, and you should come up on your calculator having it as 1 foot. Everybody got that so far? All right, then for our inches, we're going to put in 11 and then hit the inch button. It is right next to the foot. So right now, your calculator should say 1 foot, 11 inch. And then to put in a fraction, I push 3 and then this slash mark here and then 16. And it should look just like it does up there, 1 foot, 11 and 3/16. I hit convert, which is this orange button, and then I hit inch, and it's going to convert it all to inches. So that's 23 inches and 3/16. But that doesn't do me any good for trying to plug it into my formula. So I'm going to go ahead and hit convert and hit inch again, and it's going to give it to me as a decimal. So that decimal then is going to be 23.18, and I know it says 75, but we're rounding to what? Closest thousandth. So 5 or higher is going to round up. So we're going to use 23.188. And then our last one, we can do the same thing to make sure that we're not making a mistake, because I can tell you one of the things that I did one time on a key, I had to redo the whole key because sometimes you get wrong numbers ingrained in your head. I had it in my head that 3 feet was 48 inches. I know that's not right, but that's what I had ingrained in my head. So I ended up making a whole key and having to redo it because I had it ingrained in my head for that key that 3 feet was 48 inches. So to prevent making an error, I put everything in the calculator. So 2 feet, 5 inch, 7/8, convert inch, It's going to be 29.875. Now I can do my math just like I was doing before. So I take my 28.5 times 23.188 times 29.875, and you get what? $19,743, so 19,743.13. And what's my measurement on that? Correct, cubic inches. We know anytime that we have those cubic inches, we need to convert it back over to cubic feet to get an estimate on our weight. So we're going to divide that by what? 1728. So we divide by 1728. And that's going to give us an answer of 11.425. Everybody get there? We good so far with that? All right, we know this is cubic feet. And to figure out the weight, we're going to multiply by our number over there that we had, which is 490. So 11.425 times 490 is going to give you a weight of 5,598. And I know that if you didn't remember we're rounding to the nearest whole. So if you were like, wait, there's a 0.25 there. Anything that's 5 or higher is going to round up. So if we come up with 5598.55, then we would have rounded that up to 5599. But since our number is 4 or lower after the decimal point, that's going to make our number go or stay the same. So if it's 4 or less, it's going to stay the same. 5 or more, you're going to round up. Everybody good with how I figured this out? All right, we're gonna do another one just like this. That way, I know that you feel comfortable with figuring out the weight of it as a solid. Once we have the weight as a solid down, then we're gonna throw some more loops into this. Because if we have a box, sometimes our box isn't always full. Sometimes we have an empty box that we're flying out. Especially if you're unpackaging something and you want to know what the weight of that box is going to be. So we'll figure out how to figure out a box that's empty. And then obviously, like we talked about, sometimes our machines come in boxes already packaged up. So we need to know what the weight of that object is inside that box. So we're going to have to figure out what the weight of our box is, and then what the weight of whatever is in the box. So what we're going to end up doing is I'll show you how to figure out the weight of the box, and then we're going to simulate filling it with concrete to be able to help you to figure out what some of these different weights of things might be. So that'll be our next step. Before we move on with that, anybody have any questions about anything? Nobody's confused about where these numbers came from? No questions as to how to put it in the calculator? All right, so before we do that, let's go ahead and take a quick break. I will see you back here in 5 minutes. And if you have any questions while you're taking that break, feel free to ask me. I'll be happy to go over with things for you. All right? All right, we'll see you in 5.